Hello dear friends. Welcome to Romak Tech channel. Please enable subscription, likes, and notifications before watching the video. Astronomy is a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origin and evolution. Objects of interest include planets, moons, stars, nebulae, galaxies, and comets. Relevant phenomena include supernova explosions, gamma-ray bursts, quasars, blazars, pulsars, and cosmic microwave background radiation. More generally, astronomy studies everything that originates beyond Earth's atmosphere. Cosmology is a branch of astronomy that studies the universe as a whole. Astronomy is one of the oldest natural sciences. The early civilizations in recorded history made methodical observations of the night sky. These include the Babylonians, Greeks, Indians, Egyptians, Chinese, Maya, and many ancient indigenous peoples of the Americas. In the past, astronomy included disciplines as diverse as astrometry, celestial navigation, observational astronomy, and the making of calendars. Nowadays, professional astronomy is often said to be the same as astrophysics. Professional astronomy is split into observational and theoretical branches. Observational astronomy is focused on acquiring data from observations of astronomical objects. This data is then analyzed using basic principles of physics. Theoretical astronomy is oriented toward the development of computer or analytical models to describe astronomical objects and phenomena. These two fields complement each other. Theoretical astronomy seeks to explain observational results, and observations are used to confirm theoretical results. Etymology. Astronomy means law of the stars, or culture of the stars depending on the translation. Astronomy should not be confused with astrology, the belief system which claims that human affairs are correlated with the positions of celestial objects. Although the two fields share a common origin, they are now entirely distinct. Use of terms astronomy and astrophysics. Astronomy and astrophysics are synonyms. Based on strict dictionary definitions, astronomy refers to the study of objects and matter outside the Earth's atmosphere and of their physical and chemical properties, while astrophysics refers to the branch of astronomy dealing with the behavior, physical properties, and dynamic processes of celestial objects and phenomena. In some cases, as in the introduction of the introductory textbook The Physical Universe by Frank Hsu, astronomy may be used to describe the qualitative study of the subject, whereas astrophysics is used to describe the physics-oriented version of the subject. However, since most modern astronomical research deals with subjects related to physics, modern astronomy could actually be called astrophysics. Some fields, such as astrometry, are purely astronomy rather than also astrophysics. Various departments in which scientists carry out research on this subject may use astronomy and astrophysics, partly depending on whether the department is historically affiliated with a physics department, and many professional astronomers have physics rather than astronomy degrees. Some titles of the leading scientific journals in this field include the Astronomical Journal, the Astrophysical Journal, and Astronomy and Astrophysics. Ancient times. In early historic times, astronomy only consisted of the observation and predictions of the motions of objects visible to the naked eye. In some locations, early cultures assembled massive artifacts that possibly had some astronomical purpose. In addition to their ceremonial uses, these observatories could be employed to determine the seasons, an important factor in knowing when to plant crops and in understanding the length of the year. Before tools such as the telescope were invented, early study of the stars was conducted using the naked eye. As civilizations developed, most notably in Mesopotamia, Greece, Persia, India, China, Egypt, and Central America, astronomical observatories were assembled and ideas on the nature of the universe began to develop. Most early astronomy consisted of mapping the positions of the stars and planets, a science now referred to as astrometry. From these observations, early ideas about the motions of the planets were formed, and the nature of the Sun, Moon, and the Earth in the universe were explored philosophically. The Earth was believed to be the center of the universe with the Sun, the Moon, and the stars rotating around it. This is known as the geocentric model of the universe, or the Ptolemaic system, named after Ptolemy. A particularly important early development was the beginning of mathematical and scientific astronomy, which began among the Babylonians, who laid the foundations for the later astronomical traditions that developed in many other civilizations. The Babylonians discovered that lunar eclipses recurred in a repeating cycle known as a saros. Following the Babylonians, significant advances in astronomy were made in ancient Greece and the Hellenistic world. Greek astronomy is characterized from the start by seeking a rational, physical explanation for celestial phenomena. In the 3rd century BC, Aristarchus of Samos estimated the size and distance of the Moon and Sun, and he proposed a model of the solar system where the Earth and planets rotated around the Sun, now called the heliocentric model. In the 2nd century BC, Hipparchus discovered precession, calculated the size and distance of the Moon, and invented the earliest known astronomical devices such as the astrolabe. Hipparchus also created a comprehensive catalogue of 1,020 stars, and most of the constellations of the northern hemisphere derive from Greek astronomy. The Antikythera mechanism, c. 150 to 80 BC, was an early analog computer designed to calculate the location of the Sun, Moon, and planets for a given date. Technological artifacts of similar complexity did not reappear until the 14th century when mechanical astronomical clocks appeared in Europe. Middle Ages. Medieval Europe housed a number of important astronomers. Richard of Wallingford, 1292–1336, made major contributions to astronomy and horology, including the invention of the first astronomical clock, the rectangulus, which allowed for the measurement of angles between planets and other astronomical bodies, as well as an aquarium called the Albion, which could be used for astronomical calculations such as lunar, solar, and planetary longitudes and could predict eclipses. Nicole Oersma, 1320–1382, and Jean Buridan, 1300–1361, first discussed evidence for the rotation of the Earth. Furthermore, Buridan also developed the theory of impetus, predecessor of the modern scientific theory of inertia, which was able to show planets were capable of motion without the intervention of angels. George von Feuerbach, 1423–1461, and Regiomontanus, 1436–1476, helped make astronomical progress instrumental to Copernicus's development of the heliocentric model decades later. Astronomy flourished in the Islamic world and other parts of the world. This led to the emergence of the first astronomical observatories in the Muslim world by the early 9th century. In 964, the Andromeda Galaxy, the largest galaxy in the local group, was described by the Persian Muslim astronomer Abd al-Rahman al-Sufi in his book of fixed stars. The SN 1006 supernova, the brightest apparent magnitude stellar event in recorded history, was observed by the Egyptian Arabic astronomer Ali ibn Ridwan and Chinese astronomers in 1006. Some of the prominent Islamic, mostly Persian and Arab, astronomers who made significant contributions to the science include al-Battani, the Bit, Abd al-Rahman al-Sufi, Biruni, Abu Ishaq Ibrahim al-Zarqali, al-Burjandi, and the astronomers of the Maragha and Samarkand observatories. Astronomers during that time introduced many Arabic names now used for individual stars. It is also believed that the ruins at Great Zimbabwe and Timbuktu may have housed astronomical observatories. In post-classical West Africa, astronomers studied the movement of stars and relation to seasons, crafting charts of the heavens as well as precise diagrams of orbits of the other planets based on complex mathematical calculations. Songhai historian Mahmud Qadi documented a meteor shower in August 1583. Europeans had previously believed that there had been no astronomical observation in sub-Saharan Africa during the pre-colonial Middle Ages, but modern discoveries show otherwise. For over 6 centuries, from the recovery of ancient learning during the late Middle Ages into the Enlightenment, the Roman Catholic Church gave more financial and social support to the study of astronomy than probably all other institutions. Among the Church's motives was finding the date for East scientific revolution. During the Renaissance, Nicolaus Copernicus proposed a heliocentric model of the solar system. His work was defended by Galileo Galilei and expanded upon by Johannes Kepler. Kepler was the first to devise a system that correctly described the details of the motion of the planets around the Sun. However, Kepler did not succeed in formulating a theory behind the laws he wrote down. It was Isaac Newton, with his invention of celestial dynamics and his law of gravitation, who finally explained the motions of the planets. Newton also developed the reflecting telescope. Improvements in the size and quality of the telescope led to further discoveries. The English astronomer John Flamsteed catalogued over 3,000 stars. More extensive star catalogues were produced by Nicholas Lewis de Lacaille. The astronomer William Herschel made a detailed catalogue of nebulosity and clusters, and in 1781 discovered the planet Uranus, the first new planet found. During the 18th, 19th centuries, the study of the three-body problem by Leonard Euler, Alexis Claude Clairaut, and Jean-Louis D'Alembert led to more accurate predictions about the motions of the Moon and planets. This work was further refined by Joseph Louis Lagrange and Pierre-Simon Laplace, allowing the masses of the planets and moons to be estimated from their perturbations. Significant advances in astronomy came about with the introduction of new technology, including the spectroscope and photography. Joseph von Fraunhofer discovered about 600 bands in the spectrum of the Sun in 1814–15, which, in 1859, Gustav Kirchhoff ascribed to the presence of different elements. Stars were proven to be similar to the Earth's own Sun, but with a wide range of temperatures, masses, and sizes. The existence of the Earth's galaxy, the Milky Way, as its own group of stars was only proved in the 20th century, along with the existence of external galaxies. The observed recession of those galaxies led to the discovery of the expansion of the universe. Theoretical astronomy led to speculations on the existence of objects such as black holes and neutron stars, which have been used to explain such observed phenomena as quasars, pulsars, blazars, and radio galaxies. Physical cosmology made huge advances during the 20th century. In the early 1900s, the model of the Big Bang theory was formulated, heavily evidenced by cosmic microwave background radiation, Hubble's law, and the cosmological abundances of elements. Space telescopes have enabled measurements in parts of the electromagnetic spectrum normally blocked or blurred by the atmosphere. In February 2016, it was revealed that the LIGO project had detected evidence of gravitational waves in the previous septum. Thank you very much for being with us until the end of the video. Please do not forget to subscribe, comment, and like. So that is another educational video. God is with you.